My name is Frank Yu. I'm the Principal Application Experience Architect for Kemp Technologies. And today we're going to be talking about gaining visibility with network performance, monitoring, and diagnostics. And this concept of NPMD is really important because it gives us the visibility, it gives us insights into what is going on into your network on a day-to-day and ongoing basis that we would like to get, but we don't get with our current tools and solutions. So let's talk about, and this is important, let's talk about what the problem is, because I want to stress this. Here's my use case example. A user complains about application slowness. For example, I am on my phone and I am going to my email and my work email is running slow on my phone. My Outlook is running slow. So what do? I call my help desk and I tell them my email is running slow on my phone, fix it. You know what? That's all I am telling my help desk. And that's all the help desk has to pass on to the network operations team. So now they have to troubleshoot that some person in the company is having slowness on their email, on their phone. What is the problem? Is there a problem? So is the problem the network? Is the problem the server? And as we know, this is an important point to understand, is that these organizations within the IT infrastructure are different and they don't necessarily talk to each other. And they don't necessarily talk to each other in a friendly way. The network guys are going to say, oh, it's probably the application server. Let them fix it. And if they find out that they don't have a problem, then they come to us. And the server guys are going to do the exact same thing. This problem becomes a hot potato with little visibility to understand what is going on. You know what? Ultimately, it might be the user. I have too many applications open on my phone. I'm in a bad spot. I'm on a bad Wi-Fi hotspot. It could be my fault. So how do we change this paradigm to get to the point where we can quickly and easily and effectively fix these problems? And there's a huge impact with this. So obviously there's a loss of productivity. People don't use the applications if they don't work. If the applications are slow, then our productivity is slow. Customer churn. Customers, if you are customer facing, customers are not going to use the application. They're going to go to something else. They're going to go from your website or wherever you're using your app and find some competitor that works well. And this is true internally, not just for customers from a retail perspective, internally as well. If I have users that don't like using, for example, I don't like using my CRM software at my company. I'm going to not use it much and I'm going to find other ways to do what I want, and it might not be as effective. And there's lots of potential blind spots. We can't fix what we can't see. And this is an important point for us to continue to talk about, is we can't fix what we can't see. So we need to understand what is going on before we can even talk about how do we resolve these problems. So here, getting into the meat of talking about the technology, and Pavel later is going to go into much deeper and richer detail. What we're doing is we are taking components of our infrastructure. You can see at the top, we have routers, switches, cloud platforms, firewalls, other types of pieces, and we're going to be collecting data from them. And this is going to be NetFlow, IPFix, SFlow, JFlow, other types of flow type data that we're going to be collecting. We have the Kemp Loadmaster Load Balancer. It can be collecting the flow data as well. We have Flowmon Pro. Yes.
Can I ask a question?
Yes, sir.
Can I also receive model-driven telemetry on the performance of the environment?
Can you see receive what kind of telemetry? I'm sorry.
Model-driven telemetry. So instead of only NetFlow, also driven telemetry on how the switches and network is behaving.
So you can collect other pieces of telemetry as well. So we can collect the flow information gives us the bulk of the information, but there's other pieces that you can incorporate into your overall picture in terms of SNMP information, in terms of logging information, but other pieces. But the core bulk of what we're talking about today with the network performance monitoring diagnostics is really this flow data and the richness of the flow data, as well as you can see here on the right-hand side on the top, the Flowmon probe, which acts as a software probe that can then collect that data as well as enrich that data with other context into what we see in the center of this Flowmon collector.
Hey, Frank, this is Jeremy. Just to kind of I guess, re-ask Peter's question. I understand flow and the benefits of the kind of collecting and visualizing flow data, and it's hugely important, and I think we would all agree. But one of the big challenges that we're facing in network observability is the correlation of other sources of information, whether they are, say, TACACS logs for Bob changed this configuration on this interface, to sys logs like this BGP session went down, and correlating it to the fact that Bob made a change on that interface, or perhaps looking at interface metrics, even if they come from SNMP, like I'm seeing interface CRC errors on this interface that Bob touched because maybe he changed, some aspect of it. It's the correlation of all of these different metrics, whether they're SNMP based or they come from streaming telemetry, what Peter referred to as model-driven telemetry. Mm-hmm. All of these aspects of network observability brought together in a platform so that we can see the correlation of this information is I think the missing piece, at least in my mind, of how we approach operating our networks. And so what I'm very interested in is understanding, is Kemp, does the Kemp product allow us to send all of that data into the system for correlation and maybe even causation? Or are we going to focus explicitly on just kind of the S-flow aspect of this problem?
So let me try to talk about this from two perspectives. And one is, from what we're talking about today, is primarily the flow collection and what we can do with the flow data from a heuristics intelligence perspective in terms of managing this. Having said that, in terms of logs, errors that we're seeing that we might be collecting from SNMP stats, for example, for CRC errors or things like that on a switch, firewall logs, other types of information in terms of security components, we have other elements in our tool bag that work together. For example, I'll tell you right now that we are not a SIEM. We're not a security element manager. We are not going to be using my telco background, we are not an OSS/BSS system. We're not designed to be. And should there be an overarching big component of like an OSS/BSS type model that takes pieces from the flow collection system, like the Flowmon collection system we'll be talking about today, and taking pieces from the SIEM collections alert system and from other pieces? Probably. But currently today, we are focused on extracting and taking the benefit of what we can from the flow technology versus taking all the different pieces, which becomes a much, much bigger pie, a much, much more complex pie to try to understand and comprehend. Does that make sense?
Yeah, I mean, I get your answer. I think the short answer is flow only in this presentation. That is correct.
That is primarily correct. We'll be talking primarily flow only in this presentation. That is correct. So again, real quick at this overview, we have the Flowmon collector in the center, which is our flow collector, and it is providing the functionality in terms of what we can do in terms of what it can display, whether it's going to be this NPMD, this network visibility, this network performance management thing, whether it's going to be anomaly detection for security threat of application performance monitoring, DDoS detection, and analysis. So these are different components in terms of modules that we have built into the Flowmon architecture that we can enable based on the central core repository of flow data. And again, Pavel will go into more detail on this architecture and what we can do, but this is at least the first step in terms of you understanding what we're talking about in terms of the framework. And just FYI, you can see on the right-hand side in terms of support for virtualized and cloud platforms, absolutely 100%. So collecting the flow type data from AWS, Azure, GCP, Google Cloud, and from virtualized platforms like Microsoft and VMware, et cetera, is all supported within this platform. So again, focusing on the flow data, what we're really trying to do is we're trying to give you some way to extract intelligence from this flow data, because number one, flow data, there's a lot of information being sent to the collector, and it is being stored And we now need to find some way to extract the visibility without somebody manually going through with spreadsheets or something else to try to figure out what the heck this flow data means. That's the purpose of these flow solutions. So number one, we're going to have some sort of dashboard that gives us some sort of high-level visibility. And it gives us visibility at multiple levels in terms of the overall traffic, the health of the environment, security events, et cetera, et cetera. And what we can do with this is give you a deeper dive as we go through with this interface, giving us detail about specific flows or groups of flows based on the application, based on the source destination, based on the type of protocol, et cetera, and give us status and general rough status in terms of how healthy those flows are, how recent they are, how much is happening, average duration of the flows, how long have they lasting, what is the response time in terms of the flows or the TTL or other types of information that we can collect. We can now start clicking down easily and drill down to this level of detail. We can even start creating groups where we can look at the number of flows per second or types of flows, whether it's TCP, UDP, number of packets per second, the size of the packets, et cetera. We can start getting this information quickly and easily through clicks through the interface based on what we're looking for and what we're trying to troubleshoot. To go back to my issue with my phone and my email, now the team can go through and look at, okay, is there a problem with the application in terms of load? How many people are connecting to it? How much traffic is going to it? What's the response time that we're seeing from the application for these users? And we can go into more detail where we can look at specific transactions. These are HTTP transactions. You can see going to specific URIs. We can see the transaction timestamps, how long it took in terms of how much traffic it was, the source destination, et cetera. And again, quickly and easily using this flow of information, drill down and get detail to what we want through this interface. And lastly, if we need to, we can do a packet capture. Packet capture is a little more bulky, a little more intensive, but we can do packet captures to get full details of exactly what is going on these scenarios so that we can get the root cause and show the root cause. So the really cool thing about this is that multi-level visibility where we can quickly and easily drill down in real time from a problem, from a very vague statement from somebody opening a ticket to the full root cause, potentially within minutes, all within one system. And the secret sauce of this whole thing is about decisive intelligence. It's about giving us the heuristics, the signatures, what the AI, ML, whatever you want to call it. Those buzzwords I think they kind of get munched in today's world. But some sort of intelligence needs to be put into the system to extract the valuable information from this flow data, because there's a lot of flow data coming in from your sources to understand what's going on. So you need some sort of heuristics and intelligence and signatures, like I said, to give us the details in terms of, are there anomalies, are there threats, are there issues in terms of what is going on in your network, and give me some sort of alerts or some sort of analytics to tell me you should be looking at X, Y, or Z.
So Frank, this is Jeremy. I'm really curious if you could kind of share some stories of specific examples that your customers have found through this automated analytics. You're right. We do hear the buzzwords too often, ML and AI, thrown around. And so what I'm looking for is can you talk about maybe one or two specific use cases where a customer said, with Kemp, I was able to solve problem X in a matter of minutes, whereas before I could not.
Absolutely. So I'll actually have a little slide. So after I get through this, I will get to some of those use cases, and we can certainly talk about more as well, because there's tons of really cool use cases that I can talk about in terms of what we can see and what the customer sees that they weren't able to see previously. So let me get through this real quick. So again, the device size of intelligence, it has to be smart because the flows are going through multiple components in your system, and it can understand that these flows are going through different devices, and it can correlate them. So there has to be some sort of correlation to say all these things that we're seeing are related to this one flow that's traversing multiple devices across my network, and it's all related to this scenario. So we need to be able to consolidate these things to give the decisive information. The analytics capabilities of the flow system, whatever flow system you use, needs to have this capability. And then getting in detail again, finding details about things that you may not be aware of. For example, if somebody is on my network and doing a dictionary attack, and they're doing a dictionary attack against one of my servers. In other words, they try to log on with random passwords or well-known passwords. And it can identify that, hey, we see these multiple logins going on in this system coming from these source addresses using, with this type of payload showing that somebody is trying to log on with different passwords. And here's the event, and here's all the different flows related to that event, and here's our analysis of what we think is happening and what you should do. So it's providing that intelligent analysis before it gives you the information to give you some sort of context of what you should be looking for.
Hey, Frank, Chris here. I got a question for you.
Yes, sir.
So you're mentioning some use cases like, a dictionary attack against passwords. That's the kind of stuff that's not in flow data. But when we were talking earlier, one of the earlier questions was, pretty much, is this just flow data? So one question is, how do you come to that conclusion based off just flow data? Or if there is an augmentation of the flow data, is it doing things like, I know you mentioned packet capture, so I imagine that's how you're doing it here, but, also just other data sources to augment your flow data, like, BGP and getting visibility in your BGP tables so you can actually see the network, ASNs and all that fun stuff, SNMP tie-ins and all that fun stuff. Is that data being correlated here?
So the cool thing, going back to the original question here, how, for example, with the password attack model, how did we know that as a password attack? Because flow data, for other people listening that may not know, does not involve primarily the packet payload, unless you're talking about some sort of fancier, for example, NetFlow v9 and IPFix can use extensions to put in some basic information like URI, SNI, and things like that into the flow data. But those are options. But can you do it without options? Can you do it just from the flow data from the packet header and the packet information? And the answer is yes, because there are behavioral patterns that you can learn about and understand that we can analyze. For example, for SSH login, how do we know that this is a password attack? Because there's always a sequence in terms of the packet sizes, in terms of how long the packets are. SSH is going to be encrypted, so we can't even see the payload even if we wanted to. But we can see that, and we know that in sequence of SSH, we're going to see, connection, TCP handshake, SSL connection, and then we're going to see a login, password, challenge response process. And then the connection closes because password failed and you're not allowed. And we're going to see this repeatedly. So we can see the patterns and the behavioral patterns in terms of the type of traffic, the size of the payloads, the sequence of the payloads, to really understand what is going on, even though we don't see the payloads themselves. So there's certainly some intelligence that we can put into the models in terms of flow analysis to give us details and insights that we may not have initially thought of possible.
So you can tell the difference between like types of password attacks. As you mentioned specifically, it's a dictionary attack. So you can even tell the difference between like dictionary versus just like a brute force kind of thing? Or was that just one example?
It's one example. It's one example. So, it could be, if it's a dictionary attack, chances are, for example, it's somebody going through this file, and you're going to see hundreds of attempts happening within a short period of time. So there are other behaviors that you can see versus somebody just trying to log on and failing, or somebody, because they forgot their password, tried 6 times in a row before they got locked out, or whatever the case may be. But there are, again, patterns that you can see and recognize to give you better insight into the type of things that are going on. And for example, you can see in this case, we can see messages going on in terms of somebody is running this SMTP server that's unauthorized. They're running on their machine on their desk, they're running on their laptop or something like that. And the case may be that number one.
Hey, Frank, this is Kim. I got a quick question for you.
Yes, sir.
Are you able to run some agents on the network devices themselves in order to provide some more granular, feedback on how things are going, or how do you deal with that?
So the answer is it depends, because when you say network devices, the general rule of thumb is that you can't really install agents on network devices. They have APIs that you can access, but installing an agent on a Cisco router, good luck.
I'm thinking more. Many network devices nowadays actually have the ability to run a containerized version.
Mm-hmm.
So I'm thinking if you're looking into the direction of that, or if that's too much.
So we have for the Kemp Flowmon technology, we have the Flowmon Probe, which is basically the software that you can load onto a system that can provide richer information, where it can provide layer 7 content analysis and other types of things and pass it on, to the collector. For example, one of the really cool things is that we've integrated the Flowmon Probe as an option that you can install on the Kemp Loadmaster load balancers. So now you can use the Flowmon Probe on the Kemp load balancers to send the flow data, as well as get more richer information from a load balancer, which is a great source of information. So the answer is, I'm going to say partially, because it depends on whether this device or whether you can insert this probe software into a location where you can extract the data, and whether that device or the vendor supports your ability to be able to load that on there, which is a big component, right?
Just to add to that, is there a way to install an agent all the way to the end device, like you said, your phone? Because with these days working from home, it would be nice to know, is it the local area connection, or is it, further upstream, something is going wrong? That would be kind of interesting to have that information.
I agree. It would be interesting. Today, we are not doing anything in terms of end devices. Part of the challenge here is the support for all the end devices and applications and OSs and everything else. But there is a possibility, certainly in the future, maybe we'll think about, for example, using HTTP JavaScripts or something like that to be able to push something to a device as long as, it's permitted or something like that, to be able to do some sort of monitoring. But currently, the current stance is that we are focused on the core network infrastructure today. And yes, we can get some WAN information details, but not as rich as you could if you had it installed on the device, the end user device itself.
Okay, and a very last question, I promise. What about encrypted traffic analysis kind of thing? Are you doing some sort of AI into the SSL?
Yeah, so we're getting a little deep, but I'm more than happy to answer. And the answer today is we do not do anything in terms of decrypting encrypted traffic, and there's some pros and cons to that. But in terms of AI managing encrypted traffic and be able to get some insights into encrypted traffic, even though it's still encrypted, absolutely 100%. So just because it's encrypted doesn't mean we can't get some insights in terms of what it is and what's going on. Just like I mentioned for the SSH password attack, we can look at, the sequence of packets, the size of the packets, the types of things going on in terms of that connection to be able to say, we see X happening. So you can do things even though you don't see the payload. The challenges with encrypted traffic and decrypting traffic is, number one, you need the encryption key. So you need the certificate or the keys or whatever it is to be able to do the decryption and then the re-encryption. Number one. Number two, it becomes very processor intensive to do that for all the traffic, and you need to find points in the network that you can decrypt and re-encrypt all the traffic to get the proper picture of being able to see what's in those encrypted payloads. And the third issue is then you're opening yourself up potentially to a vulnerability for man in the middle, because technically you are a man in the middle now. You're just doing it with a white hat instead of a black hat. So you need to manage that. Does that kind of answer what you're asking for there?
Yeah, to a certain degree. I think there are other players on the market that are actually doing some research into detecting certain attacks based on the traffic flow on encrypted stuff without decrypting it.
Agreed. Completely agree. There's a lot of companies and there's a lot of open source communities that are doing this type of research in terms of without decrypting, can we see tell what's going on with encrypted traffic? And it's a pretty cool field. And I've spent some time over the years dealing with it, and it's definitely a very cool because there's a lot of meta-analysis of this traffic. But again, we're kind of going off topic, but it's something I would love to talk. I love talking about over a drink or something for hours with people about these types of things. So again, details, and the cool thing is we can get really detailed in terms of what's going on, and even get packet captures if we need to, as we're troubleshooting problems with this flow analysis and detecting threats and detecting issues on the network, and get to the point where we have the root cause. We want to get to the point where we have the root cause, whether it's a dictionary attack or it's something else, to the point where I had my original problem of that my help desk and network operations now fighting with my application developers to say, whose problem is it, hot potato? Within minutes, we have the intelligence and the analytics and the data, the raw data, to give almost pretty close to a root cause, to be able to go say, if the problem is focused here, this team needs to be resolving it. And now I've also given you 80% of the process for you to fix the problem, identify and fix the problem to make your job easier. So automating that analytics and giving that expert intelligence built into the system is really the secret sauce that you're going to find with these flow technology companies and solutions that you're going to see out there. You cannot manage what you can't see. And I've been in this industry a long time, and showing my age, when I was a kid, I used to watch this Saturday morning cartoon show, G.I. Joe. And they always said, knowing is half the battle. And this is so true with what we're talking about with our networks today. For the past 30 years, we've been building networks and so busy building networks that we never spent the time to try to manage and really properly get visibility into them. NPMD is hot now because now we finally have the time and effort and this direction in terms of orchestration, automation, all these other cool things to say we need the visibility into what's going on in our network. We need to know what is going on before we can do anything. And to do that, we need this flow data, we need this visibility, and we need these other components that we are talking about through this discussion. But flow data is a critical component in terms of network performance and understanding it and getting the visibility. And the really cool thing about it is we now have a single source. We have one window. I came from the telco world, and when I walk into a network operations center at a large telco, there is a huge room with 20 different big screens and projectors all around the room displaying different tools. And if somebody has to troubleshoot something, they have to go through those 20 different tools and bring it all together with their own head and expertise in their run books to figure out what's going on. Now we're getting to the point where we have the single source of visibility for network performance, for anomaly detection, for these other things in terms of the capability of using flow technology. And we get to see things in real time. So we get to know what's going on in real time, as well as looking at things historically. So we see things that are going in the past, as well as going in the future, or potentially in the future, we can trend and we can troubleshoot and get to the root cause, reveal the bottlenecks, the errors, the problems on our network in real time in a very short amount of time because of the intelligence that's built into these flow analysis tools that you're going to see today.
Frank, Chris here again. Got another question. You mentioned that this is the one tool to replace all those screens. So, are you taking data from all these other? Because flow data, from a network operator perspective, is just one very, very, very small piece of the picture. So, are you taking data from other places and presenting that in a single point of view?
So I probably went out a little too far. I was using my marketing speak there to a certain extent. My goal here is not to replace all the tools, but I'm going to replace I can replace a large section of those tools that they would be using to be able to get the analysis and things that they would do. So again, our goal is not to be a SIEM, is not to be a log analyzer, is not to be an OSS, BSS type component, but it's certainly a component that can provide lots of diverse functionality that we would have been getting in the past with point solutions that are targeted for point products or point components. And that's what we're really talking about, because flow analysis is really about getting the broad scope of the network infrastructure information, no matter what vendor, what technology is really riding across that network. So we asked about a couple of real world scenarios, and I know I'm going long here, but I'll close it off here because this is important. Here's an example.
Can I drill into a little bit like replacing my SNMP monitoring tools with this product? You know, that sounds very interesting and alluring because, well, SNMP, but, you know, when I think of what I monitor with SNMP, I think of things like, you know, temperatures, fan speeds, like you mentioned, port up, port down. How does flow data get me that? And how does analyzing that flow data replace that tool? Yeah, I guess that's my question is like, where does this fit in there if we're replacing it?
The purpose of the technology is not to replace SNMP-based monitoring tools. The typical scenario that we see among our customer base is that they do have an IT infrastructure monitoring based on SNMP, VMI, some scripting and things like that in place to understand, is the service available, is the port up, down, is there some CPU utilization issue, things like that. So this is a common situation, but their level of visibility ends here. So when they deal with, for example, bandwidth utilization issue, they know from SNMP monitoring that they do have a saturated pipe, but they are not able to understand in detail what is going on. Or they understand that the application should be running fine based on CPU utilization, memory utilization, and so on. But still, individual employees are complaining and they do not have the option to drill down to specific network sessions to understand what is the network round trip time, what is the server response time. And our technology is providing exactly this. And it's not the traditional flow as it's being seen by the industry for 25 years. It's not plain layer 3, layer 4 information. I will be talking about our probes and about their capability to monitor the network traffic from layer 2 up to layer 7, enriching this flow data with network performance metrics, with application layer metadata. So this is giving the consolidated view on the network traffic. So the purpose is definitely not to replace standard traditional IT infrastructure monitoring. It's to bring the level of visibility into the infrastructure to completely different level. Does it make sense?
Yeah, I think so. So to kind of summarize that then, you know, we're not replacing SNMP entirely. We're replacing maybe the places where people are trying to do bandwidth monitoring with SNMP, where basically where it's not using flow data in a completely new way. It's using flow data in the place where flow data is good, right?
Exactly. And again, going back to examples, our job is not to check whether fans are running at the right speed. Our job is not to determine whether CPUs are running hot. Our job is to determine whether the network infrastructure is performing the way it should be. And CPU may be running hot, but that probably means that the application is running slow, which causes. So there are ways for us to triangulate and get data and more data points into troubleshooting situations that get to the point where the root cause is because the system is overloaded and the CPU is running hot. The goal is to get like Pavel said, is to get the additional extensive visibility into the scenarios that you would not be getting. And for example, in our use cases, the third use case, it is a perfect example of what Pavel was talking about, where you might be looking where you have a situation where you have a link capacity is being filled up. So therefore you change your link capacity. You go from whatever, a 10 meg to 100 meg circuit with your customer, or a 20 meg circuit with your vendor, or you're doing something to try to resolve the problem, and the problem still exists. And the problem is because, in this case, the problem is not because your users are using more traffic and you're becoming more popular and you're doing well. It's because you have third-party solutions that have bugs that are sending large file transfers across your WAN. And this would not be discovered in the traditional SNMP type polling things where you see bits per second on interfaces and other things like that, where we can actually identify now it's because we have these flows sending this volume of data from this source to this destination. So it's the additional insight, and again, knowing is half the battle, getting the visibility into the problems that we're seeing. And this visibility you can see, and I won't read to you in these other use case scenarios and these other customer stories, where we have situations where things are failing and it becomes hard to troubleshoot, possibly because you don't know where to look. The flow data and the intelligence gives us the visibility to say, we believe that this is where the problem is occurring and this is why the problem is occurring. And then you possibly need to go somewhere else to get the ultimate fix, in this case of a vendor fixing bugs or something like that. And let me give you another example. Lots of times we do this network assessment, network trial type thing with flow data with the customer, and we'll install the unit on site and we'll let it run, and we'll usually let it run for a week or so it can collect lots of good data over the course of the various stages of what people do in the business of work, and we come back. And it's really crazy, the data that we see, and we can tell them, hey, you got a virus on your network and this machine is affected and it's trying to infect these other 10 machines. Or we see this going on where this machine is talking to that machine across this, bypassing the firewall. There's so much cool stuff that we see that every single time we do this, the customer's eyes are completely wide open. They're like, I had no idea. They're saying, I had actually no idea this is happening on my network. And with the tools that I have today, whether they're SNMP based, whether they're log based, they're not giving me this level of information where they are, but it's so buried in this volume of data that I have to deal with, I can't spend the time to figure it out. That's what this flow data and this flow intelligence systems like Flowmon are designed to do.
Quick question for you. You mentioned that the product is, I guess, deployed at a customer prem as an appliance or a collection of appliances. Do you also offer it as a SaaS, so that as an enterprise, we're not responsible or have to deal with the toil of standing up servers and capacity planning and HA and all of that stuff, so we can just kind of point it to the cloud and let the cloud kind of store it? You guys offer that kind of a service?
We absolutely offer it in the cloud. We can offer it on a subscription basis. Ultimately, though, we are not going to be doing the management of the system. And that's an important key point here today, at least today. We are not going to be managing the system and saying, you have alert X, Y, and Z, you need to change this. We can get it up there, we can throw it in the cloud, we can put in a subscription, but it's still currently up to the customer to manage the alerts in the system itself in terms of what it's telling them to do.
So let me ask my question, I guess, a different way. As a customer, I realize I have to manage the product in terms of creating, the dashboards I want to see and the alerts that I want, to be notified. I mean, that's just part of as an operator using the product. But, what I don't want to, necessarily focus on is the toil of, I need to stand up a new virtual machine that has, 200 gigs of storage so that I can start collecting flows. I just want to tell my network devices, your flow collector is this IP address in the sky that, that is in your cloud, so to speak, so that I might be paying a monthly bill for the storage, that I'm taking up, but I'm not actually responsible for the infrastructure management of those appliances. Does that help?
It does help. And currently we don't have we have the ability to do things in terms of monitoring and managing the applications in the cloud, but we don't have anything as a full SaaS service, like, for example, a Salesforce or a Workday or something else where it's fully managed and supported in the cloud, where you don't have to deal with infrastructure. That is not available today. That is certainly that we and other vendors were looking at in terms of extending this model for those types of customers. But there are some pros and cons and challenges, obviously, on the backside to be able to support those models.
So Frank, this is Terry. So you're saying that basically you could run it as infrastructure as a service, but not as software as a service, because you guys don't manage the server. Is that right?
We don't manage the server. That is correct. So we can offer it as infrastructure we can kind of offer it as infrastructure service where you can put things in the cloud, but it's real, or you can put it on your on-prem. You can buy the software, you can buy the hardware, and you can install the software as a virtual machine on your own components and things like that. But ultimately, again, we do not have a full turnkey solution where you just turn it on and you just point your sources and you start getting the information.
Okay, thank you.
Expanding on that just a little bit, does that change the support relationship anyway? If a customer was to spin it up in the cloud, any provider and work with Kemp?
No, does not change the support at all. Again, and y'all know this, obviously y'all are very well experienced in terms of flow technologies and what it can do. And I'm not going to spend much time on this, but full packet versus flow data, we know the details. We know the benefit, the pros and cons, where the full packet gives us full analysis. But again, the problem is that it's very detailed. There's a lot of storage, a lot of information. It's impossible to do a full packet capture of your entire network for any significant amount of time. While the flow data is giving us the ability to do things where we can do things much more efficiently, but still get 80 to 90% of what we need. And to the point where if we need to do packet capture, then we can still do packet capture for those types of situations. So again, the goal here is to move us towards this possibility to take advantage of this flow data, which has existed really since really about 1995, 1996, ever since Cisco installed the RSP4s. I think it was on the Cisco 7000 routers. You remember they started doing this flow-based forwarding information-based type of cool stuff. If we want to go back in our time machine. This flow technology is really cool and it gives us lots of great benefits. And the question is, why aren't we taking advantage of? Why isn't everybody taking advantage of? If it's possible for us to get flow data from all these sources today already, it's just a matter of getting the collector that can give us the information that we really need it to do.